Welcome back, everyone. As usual, your cameras, if you can turn on, the better. For today, you have the opportunity to review two papers, and two key papers moving to the 80s. Key ideas. The software is complex, but not because the algorithms. If you notice, the problems at the beginning, 60s, 70s, is the algorithmic solution of things. And usually when you think about algorithms, it's functions, one or more, a group of functions, the use of conditions and loops. That is important, that is complex, that is something that you're going to be asked in a software engineering interview. Algorithmic is important. But the next step is the complexity of putting together several different elements in big systems. The complexity of make people, a team, working together in one project and split the work. At the end, the complexity of the software is also the complexity of the people working together and collaborating to create that software. In that scenario, in the 80s, two important things. Number one, this paper, programming in the large versus programming in the small, that is the first step going to object-oriented paradigm. And the object-oriented paradigm, that is going to end with the UML, classes, relationships, and things that I need to review with you this week. Now, starting with that big idea. You work in a project. In the previous lecture, I review with you your projects. We talk more about mistakes, things that can be improved. And hopefully you agree and you have this vision of your system right now, your first version, like this monolithic model. Is one model. Best case scenario, maybe you create two, use by default, or a couple of packages. But what you have there is a file with the functions. Now, the important thing is right now, applying the composition with the two papers that you already read, with the things that we have been working on. What you have in this one model, one file, are functions that, number one, are doing one task. Number two, are easy to understand without comments. And I take this picture of one of your projects. If I show you this immediately, no comments, no extra help, readability in use 1 minute, I think you get the idea what this method is doing, what is the input, what is the output, without any complication. Complexity for this, cyclomatic complexity, can you calculate it? One more, two, thank you. Why two? Well, is one by default plus the condition in the one. Two, our limit is 10. It's very simple. Moreover, the number of lines of code, small. The understanding of this, receiving a parameter, open a file, reading the file, put the file in a variable, returning the variable. Important to notice here, independence. I do not know what this method is going to be used for. I know that this method can read a file, can put the file in a variable, and can return that variable with the content of the file. I have no idea, doing this method, what is going to be the format of that file? What is the content of the file? What is going to happen with this file after I read it? This idea of independence, I do something and I don't care what is going to happen with that. It's a component. That is something that you should keep. This exists with the structural paradigm, with the first two papers. You are going to notice that this idea is going to be there still in the good practices today. Task, function, independence. I do something, I don't care about what happened before or after. I hope that one of your methods in your project one that you are going to reuse is something like this. Second, a different one, the beginning of the translation. And I ask the same. It is easy to understand this method. It is easy to know what this method is doing without any comment, without any specific documentation. And with the context that you have right now, it's like, well, this method is going to do something, translation. The input, the thing that is going to be translated is this array of tokens with the strings. Maybe the data is different than the one that you have. The structure of the data here, it could be different. You have a vector, you have tokens, maybe, whatever. The data that is going to be used, but what is going to be happening with that data is go to another method, and the only thing that I have here is do that several times until I do not have more information to process. Again, another example in a different way in which I understand what is happening. Maybe I have no idea about what is the input, what is the data, unless I have the context of the project that we're doing, but still it's okay. It's one task, the step of the task is clear. The input is clear. Here, no output for the void. Something is going to happen. Maybe to the screen, something is going to be printed, but officially the output is the return of the method. The method is not returning anything. It's going to do some process, done. And the process is just one while. Everything that we review, something that you should have, your methods, task, easy to understand, every single step. Input, output. So far, fine. Moving forward, something that I described to you is we start with this language, this translation. And we want to move. We want to move, and I give you some ideas of things that I want to do. We want to move, and maybe now we want to have variables in the language. We want to move, and maybe we want to add conditions inside of the parentheses. We talked a little bit about this before. It's like, well, it's all about adding new methods in the translation. It's all about now, instead of only check instruction, check if, check while, probably we're going to have check condition or check variable, more methods. Those methods probably are going to be similar to the ones that we have already, if conditions, loops, nothing fancy. Whatever complexity I add here, if you have been following the project, you can have this idea like, well, you can add as many items as you want to the language. The only thing is more methods, more checking methods in the translator. Yeah, that is one thing. The second thing, here, I am introducing new words. I am introducing new types of elements. We do not have numbers before. Now I am thinking about numbers. Moreover, in some point, what about this is a number, but this is a number, but probably that one is also a number. I want to include these elements, different formats, different categories, probably integers, hexadecimals, floating point numbers. Can we do that? And if so, what is going to change? What do we need to do for more categories of tokens? At this point, it's like, well, reading the file is not going to change. Here, the complexity, hopefully you agree with me, is split the line. This method that is called from after you read the file, that one is the one that is going to increase the complexity. Moreover, that method, split the line, that method that cut the words and then review what is the category of the word. Could you agree that it's becoming complex, very complex? So far, your assignment one, if you remember that method, the one to identify the words, is only identifying names and keywords and delimiters. And already is a lot of if-else. That method was close to the 10 in cyclomatic complexity. What is going to happen with that method if we start asking for more items, for more conditions? You know what? It's going to become a problem. Moreover, it's going to become a problem, and it looks like the customer is going to continue asking for improvements, for new things with the tokens and with the translation process. I think we are in a point in which we start with a system, very easy task one, very easy task two. But we have this customer that is asking for modifications or extensions in both sides. We need to start thinking about that. Extensibility and modificability in our code. We need to change the paradigm. That idea. Hopefully you agree with me that the next version of your system can be 2 modules instead of 1. Mandatory, at least 2. 2 modules for what? Can you help me? What could be the best split in 2 of your system? Could we agree that lexical and translate is 2 different tasks, the big one, and therefore they can become 2 different modules, 2 different files? And if we do that, you know what is the advantage of having 2 files, 2 classes or whatever? Now you can have 2 people working at the same time in the system. If you have only 1 file, is 1 file, 1 person. You can ask for pair programming, still is 1 person and the helper. 2 files, 2 people, or 2 person programming if you want. Pair programming here, pair programming here. 1 is working with the lexer, 1 is working with the translator. You split into the system. Module, people, at least 2. These 2 is according with the modularity concept that we reviewed first, 2 big tasks, 2 files. Can you think about another one, like 3 instead of 2? What could be something that you can put outside of one of the modules? Well, the file operations are already outside. I mean, you are not programming the file operations. It's something that you are using, buffer reader or file and so on. You are using that from the libraries in Java. So technically that is already outside. But from your program, something that is kind of key, the most important element outside of the functionality, the tokens, yes. You have here all the things that are related with lexical analysis. You have here in one module, read the file, split the line, and store the tokens. You have these 3 elements, and I think so far they are happy in one module. In the other, you have translate. And well, translate have a lot of helpers because translate is the one that call this check method and check instruction and check while, if, and so on. And we're going to create more. So these 2 modules, the one with 3 methods for the words, the other with all the methods for the translations, they are happy there. The big problem, something that is becoming an issue, and if you remember, the second paper that we read is, if we identify an issue, if we have a problem, it's a good idea to put that problem in its own model. And something that you can review in the previous lecture is our main problem right now. The main difference among your solutions is how do you handle the tokens. Take a look to the slides from the previous lecture. Basically, every one of you solved the problem, and every one of you, most of you, 99%, this is very similar. This is very similar. Big difference. The point of conflict, the point in which we cannot reuse our systems is how do you handle tokens? It's not the only one, but one of them, the most important maybe. And according with partners, it's like you have a problem with your tokens. Disconnect the tokens, isolate the problems. Idea. We need to have these three components, three modules, the lexer, the translator, and somehow we need to put the tokens outside. This is the beginning of your next assignment. Now, before we do this, because one thing is to split, but the other thing is the connections. You are asking me for 3 files? Good, I can give you 3 files, token.java, lexer.java, translator.java, 3 files. The problem is not to split. The problem is what is going to be the relationship between those files. There is going to be inheritance between them. We're going to move to inheritance. There are going to be used method calling other methods in any of the models, or we're going to put some kind of layers. We're going to limit which model can call the others. Those kind of questions, the answers is something that we need to review. Anyway, 3 models. And then let's talk about programming small and large, because this was our small, the first thing that I asked you to do. We need to move to the large. This one is not still the large, it's just moving in that direction. Probably I want a full compiler. I don't know. Programming in the large. Timeline. We were here. Question for you in the exam. Key idea of the first paper, weird. Key idea of the second paper, partners. Partners, do you remember key idea in 2 words? Partners, key idea. No. Abstraction, yeah, information hiding. If you mention abstraction, well, it's one way of abstraction, but specifically we're talking about information hiding. Yes. Nicholas Wright, the first paper, key idea, 1 word, or well, 1 sentence. Refinement in steps. Some people make the mistake, decoupling. That is the topic. The paper talks about decoupling, but the paper is talking about a very particular type of decoupling that is top-down. And inside of that particular thing is talking about a very particular way of doing the decoupling top-down, and is stepwise refinement. So the paper is not about the global decoupling or about everything that you need to know about decoupling. It's about one specific and particular approach to decoupling. In the same way, the other one is about information hiding. That is a very particular way of implementing abstraction. So when you mention decoupling or abstraction, something that I want to mention and be aware for the exam is you're mentioning the topic, not the specific. An if condition or a while statement, they are elements in selection and control change. If you tell me, oh, programming, well, yeah, they are related with programming, but more specific. Anyway, we talk about this, information hiding, refinement. And from here, the paper for programming in the large, 75. 5 years, programming in the large, is going to be 10 years for the paper in object-oriented thinking to come out. From when we are 5 to start thinking in large, 10 to start thinking in the people need to know, need to work with object-oriented, 15 years. And what happened with these two papers? Number one, programming in the large. The RAM. This guy basically put in a paper something that was around the community at that time. The complexity of the software is become crazy, and we need to teach the people, we need to tell the people that is developing software that there are two categories of software developing, that there are two paths to create software. Two paths. Yeah. Path number one is, well, you can do your programs and the only thing that you do is coding. You know the language, you are solving a problem, use the language to establish the instructions for the computer. If the computer do what you want, good for you. These guys say, if you do that, that is going to work only for small systems. In your programming classes, it's the classical example of doing the house for the dog. You do not follow the same approach to build the house for your dog that you follow to build your home or any of the big buildings around the campus. For the house of your dog is prototyping. You can create prototypes. In some point, one of the prototypes can go to production. You do not need to have a blueprint. It's just sit in front of your computer, start writing instructions. It's going to work. Large. Large. This guy mentioned 3 key ideas, 3 key concepts. Number one, programming. Can you help me? What is the difference between programming and coding? Is the same? Programming considers design. Yeah. When you think about, we need to teach kids in the school coding. When you think about all these coding skills idea, coding is about the language. Coding is about understanding that you can do whatever you want with loops, conditions, and instructions. Coding is about your flowchart diagrams or your activity diagrams. That is coding. One way or another, knowing the language, knowing loops, conditions, and instructions, you achieve your goal. It's like knowing how to use the hammer and put together things for the house of your dog. When we talk about programming, we're talking about design, the beginning of design at least. Design. What kind of design decisions you take when you are programmers? What make you programmers versus coders? The first thing, that the structures. The first thing that you learn as a programmer, the first thing that moves you forward from coders to programmers is you're able to identify relationships and components. Yes, that is design. In particular, relationships between data and actions. That relationship, data and the actions related with that data, the first moment in your life when you know that there is something else that you know in the language, that you know, learning the keywords in Java, is when you start reviewing data structures. When you start reviewing data structures and you know that you have arrays and linked lists, dynamic and static, in that point, the next time that you develop a system, you take the decision of using dynamic memory or not. It's going to grow the data dynamically or not. We're going to follow an implementation that is recursive, or we're going to work with something with iterations. If you have worked with trees, you have this thing. Are we going to use a tree and all the methods are going to be recursive, small, easy to read? Or we are concerned about performance and we're going to work with something with loops? Performance, easy or hard to read? Decisions. Now, this guy moved to the next level. You know what? The developer, the programmer, they are doing design, but we need another level here. The next level do not exist with that name in that moment, but it's going to become what we know as the software architect. The software architect, yeah, someone needs to take care of the big picture. Someone needs to think about the system, like the trees are important, but we need to have the vision of the forest. Someone, and cannot be the programmer, because that guy is focusing one of the trees. And if that guy is working the tree, that guy is not looking to the forest. We need someone else. We need someone that maybe is not working in a particular tree, but need to help the others, the ones that are there, to remember that that tree is just one element inside of the full system, what we call the forest. And when we do that, the limits between the modules, the limits between the elements, the limit between the trees become important. Because so far in the previous approach, it's like just put your methods in different files. But yes, from one file to the other, you can call any method that you need in any moment. We didn't review any rule that limit whether or not you can call a method. The only thing that we have is vague ideas about split in different files, different methods. But you can make a crazy thing like you can have one module here, 1, 2, 3 methods, 1, 2, 3 methods. And you can go as crazy as everyone call everything, or you can have exactly the same tree and do something more elegant, like, well, this tree communicates, and this guy communicates there, only one connection. Each circle is a method. The box is a file. Split is good, but if you do this crazy connection, call of the methods, this is a sad face. This is what we want. We need to think not only about the quality of the source code and the methods, but the quality of the big picture, the architecture. And that is the key idea with this programming in large trees and the forest. Okay, now why? Just because look better? Just because if I show you these pictures, this looks like clean and easy to read, what is the goal? The goal is, according with what you read, we are always thinking that something can fail. And if we assume, for instance, that, you know what, this model is wrong, it's failing, the methods there have problems, the programmer that did this is not so good, let's change this for another one. Like when something is failing in your computer or in your phone or whatever, you go and replace the element that is failing, right? So if we want to do that, and we have the scenario 2, you can remove this, put another one, and your only concern is what to do with this connection. Your only concern is to make something to be able to connect this with the new method that you could have here. There is only one point of connection. You want to make that match. That is going to be your concern. Here, if you think about removing something and replace, having a lot of connections is going to be crazy. Problems? Easy. This is what we want. The connections are important. And the people notice that. Connections. It's not anymore about the elements. The problems are moving to how do we connect those elements, not the methods, the modules that have those methods. So far, hypothetical ideas, but hopefully you are thinking right now like those boxes looks like classes and all that crazy connections, aggregation, composition, inheritance. This is the beginning of the people thinking about those kind of relationships, defining those relationships later. Anyway. Key ideas from the paper. It doesn't matter if you work in a project and you do top-down, like the proposed by Nicholas Wright, or you do it bottom-up. It doesn't matter. Split is the important. The coupling is the important. Okay. The composition, but not only the composition, also is valid to apply composition. Something that happened here is sometimes some people start with the big picture and go down to the instructions. But it's also valid to start with the instructions. And in some points, you need to split. You can have the problem of decomposing things because the thing is too big. But the other problem that also exists is I have a lot of elements. Some point we need to put together those elements in elements that are a little bit bigger. Balance. Top down, bottom up. For the first time, we're going to talk about split the software, vertical and horizontal. Do you remember the names today for those divisions? How do we call a system when we split the system in horizontal way? So we have 1, 2, 3, and more. What? Talking about architecture, do you know the layered architecture? We call layers those divisions, multi-level. We're moving to that field, horizontal layers. Do you know what is the rule with this? What is the reason of these layer things? I have 3 modules, 3 classes, 3 files, and I want to put them in different layers, A, B, C, one in each layer. Can I connect? Yes, that is the key idea. Guys, you can tell me that you are using layers, and that basically means that you can connect B with C, you can connect A with B, but if you connect A with C directly, that is not layers. The rule is, as you mentioned in the chat, when we are defining layers, when we are doing this split in horizontal, what we are doing is to define rules about, okay, guys, we are three here, is I am A, you are B, you are C. You know what? We're going to work in this layer approach. You A, you cannot talk with C. You two guys cannot communicate because in that moment we are not in this structure. This is good for some solutions, not for everything. We need to review them, but we need to talk about architectural patterns later. But this is the beginning, 75 layers. Now, what about the horizontal ones? What about things that split? Not in this way, this way. Do you remember one way to split things in columns? Are you familiar with model view controller? If not, don't worry, we're going to talk about it. But model view controller is, we're going to split the system in the views, the graphical things, the functionality, the model, and something called a controller split. It's about layers, it's about different levels of access to something. No, it's just we need these three elements, and this one is going to be connected with this one, and this one is going to be connected with this one, and this one is going to be connected with this one. Yeah, they are going to be at the same level, so they can connect as they want. There is no limitation as before. Can I have in one layer these three guys, the model, the view, the controller, but then I can have the model connected in another layer, maybe the data? And the answer is yes. You can split a system horizontal and vertical. A common example, a typical example, you have the data, the database in one layer. Above that one, the system. And if your system apply model view controller, well, you have that split in three, horizontal, vertical. We need to talk about this, use mentioning things that maybe you know, and we need to review. And everything starts 75 with these ideas of we need to move to the programming in the large. Now, for the first time, hopefully you notice, we're talking about this, public and private. Public and private, like scope. For the first time, we're talking about, you know what? I have this model, it's not a class yet. And some of the methods that I have here need to be accessed by another model. Later is going to be another class, but some of this should not be. Why? Because those that can be accessed from the outside are going to be one connection. And for some of the methods, I do not want to create connections. Some of the methods should be only for internal use. In the lecture, which of your methods is only for internal use? In the translator, which of your methods are only for internal use? Which of your methods in the translator or in the lecture should be private, only for use internally? Can you identify them? Or the opposite question, which of them should be public? Those methods in the translator that start with the check something, can you agree that they should be private? They are helpers to the only one that should be public, translate. Think about it. I have this module do translations. the only public method, the only thing that I want to ask to that module is translate. Internally, all this check, whatever, they are methods that are inside. They should not be known outside. For the lecture, it's a little bit more tricky depending on your implementation, but following the same idea. One method could be public, the one that I asked to work. You are going to notice is going to be the constructor. We're going to construct a lecture. We can pass as a parameter the file that lecture needs to read. And internally, that constructor can read the file and split the lines and all this stuff. Best case scenario, only one point of contact. Best case scenario, only one service or one public method. That best case scenario do not exist. You're going to have a group of publics, but also a group of privates. Another decision in the design level. What is going to be public? What is going to be private? And the last thing in the paper, they mention hierarchical decomposition. They mentioned this idea of, you know what? It's a very good idea to have a root and childs, and it's a good idea that the childs have childs. If somehow we can put in the software this idea of connections between the modules, connections between the task, and we have a root for them, that could be very useful. Why? Why a hierarchy is something useful? Why several different things, not only in programming, but in the world, are hierarchical? How? Why? Easy to modularize? Yes. Why? Reusable? Yes. Why? Why is good to break down the task like a tree? Why not in a different way? Those tasks are break down as a graph. Why the tree is better? Well, this one somehow is easy to understand. It's very similar. You know why? One reason. Because of the root. There is associations involved. The advantage of the tree is the root. Why the root? Think about this. Top down. The idea with a hierarchy is that you have one. If you know the boss, if you know or you communicate with the top of the tree, everyone down work for you. We need to talk about that public private between the root and the others, but yet something that is going to happen. And the abstraction of using a tree or a hierarchy when you are doing programming is exactly the same abstraction that you use in other aspects of the life. You do not want to talk with everyone in ASU. You have a problem, and usually you go to the head of the department that can help you, to someone that is maybe the facade, this top. And that someone probably is not going to solve your problem, but is going to have someone else in the back helping with your problem or helping with the work that you need done. You asked me about your grades. I am not going to grade your assignment, but I am going to ask to the TA to do it. I am the root of this small tree, the instructors and the TAs. You can imagine several different scenarios. Your communication is with the root. The root have down elements. When you access the root, you can have access to the elements. And this is true in one particular thing that is going to become key idea in object-oriented programming. Object-oriented programming, can you agree with me that this hierarchy is going to become what? What is the thing that you put in a hierarchy in object-oriented programming? The classes, right? And how do you create that hierarchy? Inheritance. And tell me, why inheritance is important in object-oriented programming? There are several different reasons, but one is the most important. What is the most important reason? Because inheritance is a priority in object-oriented. Reusability, yes, but specifically how? And extensibility, how? One key idea in object-oriented paradigm that only can be achieved because of the inheritance. Can you complete? Yeah, thank you. What is the connection between this polymorphism and all this inheritance tree stuff? What is polymorphism in object-oriented? You can have a variable, and that variable, the data type of the variable is this root. Think about a variable person, a variable employee, the top, right? Whatever, a variable object. And that variable can be equal to what? Any of the childs of that class, right? Not only the childs in the first level, but in the next one and the next one and the next one. The key idea of polymorphic behavior is you can create a variable from this class, this module, and that variable, that reference, can work like any of the elements down. I have access to the boss, and I can use whatever that boss is controlling. I have access to the father class, moving to object-oriented. And that variable, if the type of the variable is the parent, that variable can be equal to any of the childs. That concept, guys, is the angular stone of what we are going to review later in object-oriented programming. Almost every problem, every attempt for reusability, extensibility, is going to involve one way or another a hierarchy of classes with the use of polymorphic behavior. Moving forward. Okay, key ideas, 70s, 10 years. This guy, who is this guy? The most important thing, unit testing JUnit. You know JUnit, you use JUnit, right? This is the guy together with this other guy. Who is this guy? These two put together JUnit, you know JUnit. Now I am curious, Eric Gamma, that name ring the bell? Is someone that you know or maybe should know? Oh, not him, but his work. Eric Gamma in software engineering, design patterns. Thank you, Gang of Four. Yeah. We're going to talk about that, but this guy is one of the four that propose the patterns, design patterns that we're going to review later. So design patterns and JUnit, and there is this paper about object-oriented thinking, and 89. Key ideas with the paper. Key ideas. In 89, these people is asking, please teach the students the concept of objects and classes. Period. Yeah, in 89, the people is programming with the structural paradigm. In 89, the people is worried about recursion and functions and so on. This paper is one of several that ask the people to start teaching object-oriented paradigm. And key ideas there, key ideas of the object-oriented paradigm that the paper mentioned the people should know. Those three. Classes. Good news, I do not need to explain to you what is object-oriented paradigm. Good news, I do not need to explain to you what is a class. You already know it. So help me, what is a class? Is a module? Is a task? Is a method, a function? What is a class? The definition in the dictionary. You can give me example, but I am looking for the definition. What is a class? It's a collection of what? Methods. And well, the blueprint is going to be the class diagram. The blueprint is going to be not only the classes, but also the connection between them. Okay, one class is attributes and methods. Thank you. Attributes and methods. A group of functions that now are going to be called methods. We're going to move the name used for fancy purposes, but they are functions. What we call before functions now are going to be methods. And the variables that all those methods need. The global variables for that method that now, for fancy purposes, are going to be called the attributes of the class. What we know as a module before, now we're going to create classes. The first introduction of classes is to replace modules. And instead of thinking about modules used as functions, methods, now we're going to introduce also the idea of each class is going to do task, but each class is also going to do information hiding. Each class, each module is going to have variables and functions that should be together. Each class is going to have public elements that can be used for others. Each class is going to have private elements. And this idea of public and private is going to apply for both the task, the actions, the methods, and the variables. I am not telling you anything new. It's basically what you know about what is inside of a class, the scope, the attributes, the methods. You read the paper and it's just the beginning of what you are taught from the beginning of your undergrad years, right? 89. Now, classes is easy. What is a responsibility? We talked about this before, but now I want to match a responsibility with classes. What is a responsibility and what is the difference between responsibility and task and steps? Steps, instructions. Instructions inside of methods. Methods, task. Responsibilities, multiple tasks. The responsibilities are going to be now not from the modules. Forget about that. Now we're going to put a responsibility in one class. Talking about your homework, if we move to object-oriented paradigm, I ask you for 2 modules. I am asking you for 2 classes. One class is going to have the responsibility of lexical analysis. The other class is going to have the responsibility of translation. 2 responsibilities, 2 classes. Each class with the task, the methods now, and the variables that the class need. Moreover, I asked you for 3 classes, not for 2. The other one, the class token. Remember that we have this issue with the data, with the tokens? That class token is going to have a responsibility. What is going to be the responsibility of the class token? It's going to be one of those classes that instead of do something, help another class to do something, that responsibility for the class token is going to be mostly information hiding. Hiding the complexity of working with the tokens. It's going to have methods, yes. Task, yes. Public and private, yes. Mostly public. Getters and setters. Remember, information hiding. Control the structure of the data and provide access for getting the data or modifying the data. We're going to have 3 classes: token, translator, lexer. 2 with responsibilities that are about the functionality. 1 with responsibilities that are about helping with the data. Collaboration. Before talking about classes and object-oriented, the only collaboration that exists, calling a method. All the connections that you have in your assignment right now is one method call another one. That's it. There is nothing else. With object-oriented, help me. There are 3 kinds of collaborations that we can use to connect classes. Which are those 3 types of collaboration between classes? Yeah. Association. Okay. Aggregation composition. One more. I am using together aggregation composition, small difference between them, but they are in the same category. I am sure that you remember use. I am sure that you remember has. Having. Has is aggregation composition. Using is association. And one more, inheritance. Those are the 3 collaborations that you have between classes: is, has, or use. And the fancy names, the correct name for that is inheritance. Inheritance, you want to remember, we can be talking about generalization or specialization. Inheritance, having, aggregation composition, and using, association. Question: how do you know that if I give you a source code, 2 classes, what is in the source code? What do you have in the source code that tell you that this class is using this class, that there is a collaboration between these 2 classes, and the collaboration is an association? What does it mean in terms of programming? Association. Thank you. Calling a method is what we talk association. Calling a method is using. All your relationships right now in your assignment, all possible relationship between modules before object-oriented, the only possible relationship is this one, association. When we start with object-oriented, what we did is include these 2 more. Tell me, in the source code, how do you know that you have aggregation composition? Class A, class B, they are connected with aggregation or composition. What is in the source code that tells you that? Hopefully that summarizes what you have there. You have a variable, you have an attribute. Now, let me be clear. You have a variable, yes. You have an object, yes. That variable, that object should be global, should be an attribute, should be something that is outside of the methods. If you have a variable that is an object, but is a local inside of one of the methods, that is not aggregation, that is not composition. It should be something at the class level. because it's a collaboration between two classes. So if you have an attribute and the type of the attribute is in the name of another class, those two classes are connected. Those two classes are collaborating. In particular, the collaboration is an aggregation or a composition. We need to review them in details, but calling a method, association, having an attribute, aggregation, composition, and well, inheritance is the easy one. Inheritance, you have an extend in Java, right? Or some kind of notation in the language that allow you to tell that one class is the parent of another class. And you already know the consequences. Now, when we have the parent and we create a child, that we call it a specialization. Creating a child, having the parent, is specializing the class. Specialization is inheritance. We are just talking about we are creating the child. I am doing a new class, and that new class is going to have as a parent some class that already exists. The opposite is called generalization. If you have two classes and you want to connect them with a common parent, usually what you're going to read or what you can say is, well, we're going to generalize these two classes, which basically means we're going to create another class used to be the parent, and we're going to connect them with that common parent. You have two, you're going to create the common one, or you have the parent and you're going to go down, top down specialization, bottom up generalization, just for you to remember. Good, but both inheritance is. Okay, by the way, one of the most important things with this is you want classes, you want responsibilities, and the collaboration become the most important thing for the people to share. The collaboration become the connection between the elements, this relationship for the design. This guy, the same one that is asking for object-oriented to be public between the students with this thinking paper. In a different one, is proposing ways to represent those relationships, those collaborations. One of the main things that happened in the 80s is, okay, we have these new elements. It's not the functions anymore, the classes. And now we have these several different ways to connect the classes, well, 3 ways. And something that we want is the possibility to represent that in a blueprint, the possibility to represent that with a picture that we can share with the developers. And if the developers understand the picture, the developers can create the software. Doesn't matter which programming language they use. Theoretically, at least, I can share you the blueprint for our assignment. And you can program that in Java, C, C++, same diagram, different source code. This author proposed a diagram. However, as you can know, several different people propose diagrams, a lot. Use a picture of what happened. You notice in the 90s, everyone was proposing diagrams for classes. Hopefully you know at least 3 of the 5 names that I highlight. Hopefully you have read books from 1 or 2 of them. Several different people working around representation of classes and relationships. One of them is going to be key in all this, but is going to collaborate a lot with another 2. And we have the gang of 4 for patterns. We can have the gang of 3 for UML. Basically, what we have is these 3 people working in different proposals for diagrams, And in some point, they are going to say, well, let's put together our proposals and let's have a fancy name for what we have done. And that fancy name, UML. Yeah, the UML that you learn in 360, all these diagrams. It's not one person, it's a group of people and different work. And you can notice all the connections. Even though I am mentioning these three, well, they use things from different persons working here. But the important thing is we are going to move forward to this, 2005. So I go from 75 with programming at large to the 80s, late 80s with object-oriented thinking. And the most important thing now that we have objects and classes and relationship is how to represent that in a picture, diagrams, a lot of diagrams, and we arrive finally to the second version of UML and the one that you use. Do you know UML? Yes or no? I really hope yes. Everyone. At least you know what I am talking about with UML, right? Good. Okay, if you know UML, then we can start working with class diagrams. Then I can ask you for the class diagram for your next assignment. I am building the things, the small things that I need in order to ask you this week for the second version of your assignment. Object-oriented, I need design, and I am going to include more functionality. But before that, as a summary, for the exam, for the next quiz, I need to be sure that we agree in the following things. Number one, procedures, functions, are method. They are the same, yes or no. True, false, one question in your exam or in your quiz. The answer is, okay, good. Second, what is a module? A group of methods, agree. A responsibility, agree. A module and a class are the same? A module and a class, the same, yes or no? No, okay. They are not the same. Two things. We start talking about modules in the procedural paradigm. In the procedural paradigm, what we reviewed before, a module is a file with methods and maybe variables, but at the end, a file. It's not the same of a class because you cannot apply inheritance to a module. It's not the same of a class because you cannot apply all this relationship with modules. A module do not have class name and the curly brackets. A module is just a file. In the procedural paradigm. In object-oriented, do we have the concept of module in object-oriented programming? Yes or no? What is a module in the object-oriented paradigm? It's not a collection of methods anymore. That is the definition in the structural paradigm. We move to object-oriented, we have modules still. What is a module? A collection of classes, that is correct. Whether or not those classes are structured in packages, different idea, a collection of classes. A module is kind of the top level of the system. In the structural paradigm, the module was this collection of methods. Now, the module is going to be the collection, not of the methods, the classes. The classes can be in packages, so a collection of packages. The module still exists. What we change is what are our units. Talking about units, I just mentioned the author of JUnit, this framework that we use for testing. JUnit. The J is Java, but really the key idea here is unit testing. Can you help me? What is a unit? A method. Well, a unit. What do you do in unit testing? You test units. You test one method or one class. One method. So a unit is the same as a method? Because it should be J method instead of J unit, if they are the same. They are not the same. What is the difference between a unit and a method? A method is, no, not yet. A single line of code is one step, one instruction. A unit. When you have a method, is one method. When you have a unit, is that method and all the methods that that method is using. When you do unit testing, yeah, you test one method, but you test what that method is doing. And in order to test that one method, you need to have access to the methods, the functionalities that that method need to work. The unit is like, let me give you this analogy. If we are methods, I am one method and you are others. Method is use the unit, each of us. When we talk about unit, it's like me and my friends, me and my team. We are a unit. We are working together. I cannot explain my project if my friends, my team are not here with me because they did some of the work, theoretically. A unit is this subset of methods that collaborate, that work together. Is not that a class? No, because in a class, like we are a class, we are a lot of functions, methods. We are related. We do a work or we have a common responsibility, but some of us need to work together with others more closely than maybe others that are just independently finishing things. This is a class. The class have inside methods. And this method can be a unit because that method work alone. But maybe these three are a unit because in order to access one, that one need the other two. One unit, two units, one class. Subsets of functions inside of a class. In the unit, well, you can mock usually the classes or the external functionalities. You can mock one of these guys, which basically means you are mocking, or you are replacing that relationship with the original guy with another. Worst case scenario, or we need to talk about this, but worst case scenario, your unit is equivalent to one method. In some cases, your unit is not one method, but that method and the methods that collaborate with that one. So a subset. If you talk about a set of methods, a set can be one or more. So equal, and I will put here a plus, one or more methods is a unit. Methods that obviously collaborate or work together. Good. System. Yes, exactly. But I need to talk about that. But that is the idea. System, system is your full project. System, a system is a collection of classes, yes or no? A system is a collection of packages, yes or no? A system is a collection of modules, yes or no? And all these expressions is, yeah, all of that apply. A system is a collection of classes. Maybe you have only one package. maybe you decide to use several packages. One package do not exist if do not have classes inside. You can create several different packages and split those packages in several different modules. Your system is a collection of modules. We're going to review that with architecture. What is the difference between class and object? And I am sure that you can explain that, right? Class, object, the difference. The instance, right? The class is the, okay. I was almost mentioned that. The class is the template or the skeleton. The object is the instance, the variable, the one that is running in the memory. When you run a program, you have memory, you have objects in the memory. The classes are the templates that you have in your source code. Okay, for you as a homework task, the task is inside of the method, the line of code, the class, or the module. And hopefully all of you use method. The responsibility in the method, in the line of code, or in the class. Collaboration, the three types of collaborations in object-oriented. Encapsulation and accessibility. Hopefully these words, remember public, private, and protected. We need to talk more about it. Hierarchy. Why a hierarchy is important. And I just explained that before. Having access to the root. Composition, decomposition. Two key ideas. Levels. The layers that we described before. And one more thing. Linking. What is linking? If you work with Java, probably never hear that word. But if you use C, C++, hopefully you read in your compilers that your compiler is linking. What is that? Guys, something very, very important. What we are doing in programming with objects or without objects is to separate things. Separate things in different classes, in different methods, in different libraries if you want. One of the key work that the compiler have is when you have these several classes, different files, when you compile them, somehow the final project, not the source code, but the executable one, need to be connected. It doesn't matter that you have a bunch of classes, yours or from the library. In programming, when you do the programming, when you are working, we split and separate things. When you compile your project, several of those things are going to be connected. Connected, linked. When you run the program, your final one, the executable one, it can be maybe one file in which all the things that you create when you do your programming was separated. The idea of separate things is not going to affect, usually, the performance of the system. You are separating. You are creating these classes, models, and so on for the source code. That doesn't mean that your executable, the final result, is going to be in the same way. The compiler is going to connect the pieces, including the libraries, connecting the elements in compilation time, putting the things together to create one and only one executable. That is the linking process in your compilers. Java is a different case because you have the virtual machine. The virtual machine does this in real time. For others, C, C++, linking is the process of connecting things for execution. Anyway, I am going to stop here. Next class, we continue and we talk about your second assignment. Good? Any question? Okay, guys, see you next lecture. Thank you.